Everyone, so welcome to the third phase. I remain Ganiju Omotayo Abdulmajid, a student of mechanical engineering 200 level in University of Ibadan. So now I'll be solving this third question on moment. So we have a uniform meter rule. Are we together? So as I said in the first video, that uniform meter rule is always what? If the length is not mentioned, it is always 100 centimeter. So we have 0 to 100. That's the uniform meter rule. But if the length is given, like the previous one I solved, that one, the length has been given to be 50 centimeter. But in this case, they said a uniform meter rule. So the length was not given. So anytime a uniform meter rule is being mentioned and the length is not given, we assume it is 100 centimeter. That's the length of a uniform meter rule. So now it is balanced. So the uniform meter rule is QR. It is balanced on a knife edge. I told you this thing is called knife edge, pivot, or fulcrum. Go and check my first video. So we look at this. This is knife edge, which is at the 55 centimeter mark from R. So let's say distance from R. So let's say from here to here. So it means from here to here, it must be 55 centimeter. So we will just say it is 45 from this place. Oh, do you get what I just did? This is what I'm doing. If it is, okay, let's have it like this. If it is 45 centimeter from R, then what will it be from Q? It will be 50. It will be 45 from Q. Since everything has to be 100. If it is 55, you can see, read the question. 55 from R. Since it is 55 from R, then it will be what? 45 from Q. So that's why from here to here will be what? Will be 45. So I just want to write only 45. So I want to write only 45. So this is where we have the pivot. Do you get it at all? So now, or the distance from here to here will now be what? 55, as mentioned in the question. Now they said what? When a mass of 10 grams is hung at P, as shown below. Where did they hung P? The P is at where? The 10 centimeter mark. So let's have 10 centimeter. So this is where we have P, and that's where we have our 10 grams. Do you get it at all? So now what did they say? What is the mass of the meter rule? This question keeps, like, let me say, reoccurring. Mass of the meter rule, mass of the meter rule. Anytime the mass or the weight of the meter rule is being mentioned, you always place it at the center. So the mass of the meter rule, I will just locate the center. Since this is a uniform meter rule, which is 100 centimeter in length, then the mass of the meter rule will be placed at the center. And what's the center of the meter rule? Since it is 100, the center is 50. So let's just have 50 here. 50 will be above 45, will be after 45. Do you get it at all? So let's have our 50 here, and let me call it M, which is the mass of the meter rule. So now we are done. We just say sum of clockwise equals to sum of anti-clockwise. Do we get it at all? Sum of clockwise is equals to sum of anti-clockwise. But I want to break it down using right hand side and left hand side to avoid problems. So now let's have this now. So we are going to have 10 grams times the distance of this 10 grams. This 10 grams is at where? The 10 centimeter mark. The pivot is at where? 45. So what's the distance? 45 minus 10, that's 35. Why am I multiplying it with the distance? Because we are doing the topic what? Moment. And moment is what? Force times perpendicular what? Distance. So equals to, we don't have any other thing at the left hand side. So let's look onto our right hand side. At the right hand side we have M. So what's the distance of this M? The M is the mass of the meter rule, and it is located at the 50 centimeter mark. This 50 centimeter mark, with respect to where we have our pivot is at the 45 centimeter mark. So the distance will be what? 50 minus 45. So that will be 5. That will be M times 5. So this will be 350 equals to what? 5M. So M will be what? 350 over 5. And that will be what? 70 grams. So therefore, the mass of the meter rule is 70 grams. Thank you.